Alright, if you notice, we skipped numbers U12 and U13. Augmented matrices are something that we're going to learn in Algebra 2, so I figured I would talk about it later at the end of the year, if not next year. So we're going to now just go into U14. We're going to solve systems of equations using any method. Now keep in mind we've learned three methods. We've learned graphing, where we graph the lines and see where they cross and determine the solution. We've learned that we can look at an equation and determine if it has a solution by looking at the slope and the y-intercept. If they're the same, it's the same line, which means that they are consistent dependent. We've learned that if the slopes are the same, that they are parallel lines, therefore they are independent. We've learned if they have one place where they cross, they are independent, consistent, or it's actually said consistent independent. In other words, there's only one solution or one answer. We have also learned how to solve systems of equations by using substitution, and that works best when we have one variable alone. We've learned how to solve systems of equations by using elimination, which works best when you have two equations in standard form. So in U14, you get to pick whatever method you like. Just keep in mind that some are going to work better for some things than others. So let's go ahead and get started. So we have here solve negative 2x minus 4y equals 12, and x is equal to negative 8. Well, automatically, I've already got one variable by itself, so substitution would definitely be the best one for this. So I'm going to substitute negative 8 in for x minus 4y equals 12. So that's positive 16 minus 4y equals 12, because a negative times a negative is a positive. I'm going to subtract 16 from both sides of the equation because I want to try to get y alone. So I've got negative 4y is equal to negative 4. We're going to divide negative 4 on both sides of the equation, or the equal sign. Negative 4 divided by negative 4 is positive 1y, and negative 4 divided by negative 4 is positive 1. So we know that our ordered pairs then would be negative 8 and positive 1. But of course, we want to check it. So let's check by substituting both values into the original equation. So we have negative 2 multiplied by negative 8 minus 4 multiplied by 1. We want to see if that equals 12. Well, negative 2 times negative 8 is positive 16. Negative 4 times 1 is negative 4. And 16 minus 4 is 12, and 12 does equal 12, so that checks out. Let's go ahead and do another. I guess I better put the answer in, not negative 88. Negative 8 and 1. Alright, on this one we have negative x minus 4y equals negative 15, where y is equal to 6. So again, because I have one variable that is already alone, I'm going to use substitution. So I have negative x minus 4 multiplied by, I'm saying y is 6, so I'm going to replace y, or substitute y and 6. And that equals negative 15. Negative x minus 24 is equal to negative 15. We're going to add 24 to both sides of the equation, or the equal sign. And I have negative x is equal to, well, I have opposite signs, so I'm going to subtract 15 from 24. That gives me 9, and the larger number is positive, so negative x is equal to 9. But keep in mind, I don't want my variables to be negative, so I'm going to divide by negative 1 on both sides of the equation, and I'm left with x is equal to negative 9. And I know that y is equal to 6. Let's go ahead and check. So I'm going to substitute inside the first equation. So I have negative, that's part of the equation, and my x is negative 9. Please don't forget about that this negative is not the same as this negative. Minus 4 times 6 is equal to negative 15. So negative 1 times negative 9 is positive 9. Minus 24 is equal to negative 15. Let's see. 24 minus 9 is 15, but 24 has a negative in front of it, and it's larger, so my answer is going to be negative 15. Negative 15, that checks out. We are correct. So our answer here would be negative 9 and positive 6. Well, I think we have time for one more. All right, let's take a look at this one. Well, we have y equals 9x plus 5 and y equals 2x minus 2. Well, again, these aren't in standard form, so I don't think I want to use elimination. However, I do know if y is equal to this amount and y is equal to that amount, I can set them equal to each other. So that's what I'll do. I'm going to have 2x minus 2 is equal to 9x plus 5. And I'm going to solve for x. So subtract 2x from both sides of the equation, or the equal sign. And I have negative 2 is equal to 7x plus 5. Well, I've got this x over here and a number, and I want to get the number away from the x, so I'm going to subtract 5 from both sides of the equation. And I've got negative 2 plus negative 5 is negative 7 is equal to 7x. 5 minus 5 is 0. Divide both sides by 7. Therefore, x would be negative 1. Now, that would be wonderful if we were done, but we're not because we don't know what y is. So pick either equation and substitute. So I'm going to pick the first one, which is y is equal to 9. And I'm going to multiply that by negative 1 plus 5, because all I did was replace x with negative 1. Y is equal to negative 9 plus 5. Therefore, y is equal to negative 4. So I'm hoping that my math is right, but I have a chance to check it. So let's go ahead and do that. I'm going to check it down here. Hold on, I don't think you can see that. I'm going to check it using the second equation, and I'm going to also check by substituting the values that I have for x and y. So I said y is negative 4 is equal to 2 multiplied by negative 1 minus 2. And I'm getting that from this. Y is equal to 2x minus 2. That's where I'm getting this information from. So I have negative 4 is equal to 2 times negative 2, which is negative 2, minus 2. Well, let's see. Negative 2 minus 2, negative 2 plus another negative 2 is negative 4. So, yes, we are right. Our answer, therefore, would be the ordered pair, negative 1, negative 4. All right, one more. All right, our next system of linear equations looks like this. Negative 4x minus 8y equals negative 8. And the other line is 3x plus 8y is equal to 14. Now, looking at this is in standard form. So I really don't want to cost myself extra work by changing it into slope-intercept form like these are. And I really don't want to kind of burden myself by changing this into somewhere where I just get one of the variables alone, although I could. Like this one, it's perfect for being divided by 4 and then getting x alone, but I don't want to do that. So I'm going to use elimination. Well, the good thing is that when you look at this, it's already set up for me. I have same coefficients and opposite signs. It's a dream. So let's go ahead and just add those together. We have negative 4x plus 3x is negative x. Negative 8y plus 8y is 0. Negative 8 plus 14 is 6. Of course, I don't want negative x. I want a positive x, so I'm going to divide by negative 1. So that gives me positive x is equal to negative 6. So there's my x right there. And just pick either equation and substitute what you have for x. I'm going to pick, I think I'll go ahead and pick the first one. So negative 4x minus 8y is equal to negative 8. Substitute negative 4. Well, x is negative 6 minus 8y, because I don't know what that is yet, minus 8. Negative 4 times negative 6 is positive 24, minus 8y is equal to negative 8. And I'm going to subtract 24 from both sides of the equation. And that leaves me with negative 8y equals negative 32. Divide by negative 8. Divide by negative 8. Y therefore is 4. So we hope. Let's go ahead and check it. And we'll put our answer in and hopefully we are right. So since I used the equation 1 to find y, I'm going to use the equation 2 to check. So I have 3x plus 8y is equal to 14. Well, 3 multiplied by negative 6 plus 8 times 4 equals 14. Let's see. Negative 18 plus 32 is equal to 14. Well, 32 minus 18 is indeed 14, and 14 does equal 14. So we are correct. So our ordered pair, let's see, where can I put this? The ordered pair would be, I'll put it up here. Negative 6, 4. That would be our answer. So it's negative 6, positive 4, and we are done. At least for this one. I'll see you on the next one.